Good morning, class 10th. Today we are going to do the constructions on tangents, how to inscribe or circumscribe a given polygon, a triangle, mainly a triangle, and hexagon, octagon, whatever he has given, mostly triangle and hexagons. First of all, how to draw a tangent to a given circle from a given point outside the circle. We will do it with the example. I've written some question on the extreme right of the board. 4 questions I've written. I'm going to take up all those 4 questions and solve it for you. As I spoke to you earlier also, that for constructions, it is important for you to write down the steps of construction, and also it is important for you to see the videos. Some of you are asking Mr. Semwal to teach you the similar triangles again. I have put the whole lot of videos on similar triangle on circles already during summer vacations. If you go to the school website and look at your assignment, on top of your assignment, you'll find videos by me. You just click on them, and whichever class you are, whether 9th, 10th or 11th, you'll find videos there. Videos are useful in the sense that if you do not understand once, then you can repeat the video as many times as you like. It's just a live teaching like I'm teaching you now. Similarly, I've done a lot of videos, more than 100 videos I've done and put for you. The only reason is that this is the time of pandemic and we have difficulty in getting across to you. So the best possible means is through online. There are online classes going on, but since you realize there are 2 classes per subject, I didn't want to encroach upon the time of the other teachers. That is why I decided to make videos so that they can take those 2 classes, because I have only 2 classes with the standard 10, so that doesn't really matter. But I have completed everything what is required, and in case you require more videos on a particular subject, please let us know. I will create more videos for you. So let us talk about today's topic when we are talking how to draw a tangent. What is a tangent first of all? A tangent is a straight line touching the circle at one point only. And the other property which of the tangent is that at the point of contact, tangent and radius are perpendicular to each other. Wherever the tangent is touching the circle, and if I join that point to the center of the circle, that will be radius. Radius and tangent will be always perpendicular to each other. Now in your syllabus, in your course he will give you a circle of given radius, and he will give you a point outside the circle. He'll give you the distance between that point and the center of the circle and ask you to draw a pair of tangent. We'll discuss it just now in the first question. Draw a circle of radius 3.5 centimeter. So what I do is I draw a circle of radius 3.5 centimeter. O is the center. O is the center. The radius of the circle is 3.5 centimeter. So take O as center. Open up your compass. Open up compass of your radius 3.5 centimeter and draw a circle. Then he says, mark a point P outside the circle at a distance of 6 centimeter. So this is 3.5. So I want to mark a point P. Draw a line OP. OP is equal to 6 centimeter. OP is 6 centimeter because point P is at a distance of 6 centimeter from the center of the circle. Now I have to draw a pair of tangent from this point to this given circle. For that, what we are going to do is we are going to bisect OP. We are going to bisect OP. Already O has been taken as center. At 3.5 we have drawn this circle. That means this is more than half of OP. OP is 6 centimeter and this distance is how much? 3.5. So it is more than half. Whenever we will bisect, perpendicular bisect a line, we say take arcs at a distance more than half. So it is alright, it's already given 3.5. Take P as center with 3.5 radius only, draw two other arcs cutting this circle, cutting this arc. Now join these two arcs, and you will get the middle point of this line. You will get the middle point of this line. You will get the midpoint of this line. Suppose this K is the midpoint. OK will be equal to KP will be equal to 3 centimeter according to this, because OP is 6 centimeters, so half of that will be 3 centimeters. So we have got this. Now what we do is, we take K as center, open up your compass till O or till P and draw a circle. We have taken K as center, open up our compass till P and drawn a circle. That circle will pass through O as well as P, because OP is the diameter. Or in other words, we can say that draw a circle with OP as diameter. OP as diameter. If I want to draw a circle, naturally I'll bisect OP. I'll perpendicular bisect OP, which I have done here, and K is the midpoint, and taking K as the midpoint and KO or KP as radius, I draw a circle which will pass through O as well as P. Now this circle cuts the given circle at Q and R. This point is Q, this point is R. Now what we do is, we join Q to P and extend it, join P to R and extend it. PQ and PR are tangents to this circle. This is a pair of tangents to this circle. So the method is very simple. Draw the given circle. Like here we have been given a circle of radius 3.5 centimeter. So what we have done is, we have drawn a circle of radius 3.5 centimeter with center O. Then he has given you a point P outside the circle at a distance of 6 centimeter. So what I have done is, I have drawn OP, line OP equal to 6 centimeter. OP is 6 centimeter. Then we have taken OP as diameter and drawn a circle on OP as diameter. For finding out the midpoint or center of the circle, we will perpendicular bisect OP. We will perpendicular bisect OP and find K as the midpoint. Taking K as center, opening up a compass till O, we have drawn a circle. This circle will cut the given circle at 2 points R and Q. Join P to Q and extend it further. Join P to R, extend it further. This is number one. This is your construction. PQ and PR are pair of tangent. If you measure length PQ and PR, both will be same. PQ and PR will be always equal. We'll show it to you how. First, you please write down the steps of construction. Draw a circle of a radius 3.5 centimeter with OS center. We've taken OS center, drawn a circle of 3.5 centimeter. Next step is, draw a line OP, draw a line segment OP is equal to 6 centimeter. Because the point P is given at a distance of 6 centimeter from O. The point P is given at a distance of 6 centimeter from O. Next step is perpendicular bisect bisect OP. K is the midpoint. K is the midpoint. K is the midpoint. We found the midpoint by perpendicular bisecting this line. The next step is with K as center, with K as center and KO as radius, KO as radius, draw a circle. Draw a circle. I am telling you time and again that it is important to write the steps of construction. It is not mandated by your syllabus to write the steps of construction, but I would prefer you to write the steps of construction. I would prefer you to write the steps of construction. With K as center and K as radius, draw a circle. This circle cuts the circle with center O, cuts the circle with center O, circle with center O, with center O at R, Q and R, at Q and R. It cuts the circle at Q and R. Join P to Q, P to R. PQ and PR are required tangents. I have already revised, I have already spoken the construction about twice. This is the third time when I have written it, so it is third time you have to understand that how the construction is done. So we have written the steps of construction so that you understand it well. Draw a circle of radius 3.5 centimeter with center O. Then he says draw a line segment OP is equal to 6 centimeter. Why OP is equal to 6 centimeter? Because he has given mark a point P outside the circle at a distance of 6 centimeter from the center. That is why we have drawn OP is equal to 6 centimeter. That is why we have done OP is equal to 6 centimeter. The next step is perpendicular bisect OP. How do we perpendicular bisect OP? Take already this circle is drawn which is of 3.5 radius and which is obviously more than half of OP. More than half of OP's half will be 3, it is more than half. So we generally say take O as center, open up your compass, more than half of OP and draw 2 arcs. So already circle is drawn, so I am not drawing from this side. But take P as center with the same radius 3.5, I draw another arc. These 2 arcs cut each other, join them, you will get K, the midpoint of OP. Take K as center, open up your compass till O and draw a circle. This circle will cut the circle with center O at point Q and R, join P to Q and P to R, join P to Q and P to R. PQ and PR are required tangent. Now I am going to rub this off because I want to prove also that what I am talking about. I am going to prove that also, that what I am going to talk about. So that's why I am rubbing this off. Now if I join Q to O and if I join O to R, I join O to Q and O to R. In triangle OQP and triangle ORP. These are the 2 triangles. I will prove these 2 triangles to be congruent. How will I prove them to be congruent? I will say that OP is equal to OR. OQ is equal to OR radii. They are radii of the same circle. Obviously Q is lying on the circumference of the circle, R is lying on the circumference of the circle. I am joining the center of the circle to the point on the circumference of the circle. So both the points are both the lines segment OR and OQ are equal. OQ is equal to OR radian. I will say angle OQP is equal to angle ORP is equal to 90 degree. I'm saying this angle is 90, this angle is 90. Why? Angle in a semicircle is always a right angle. Angle in a semicircle is always a right angle. When I have drawn this circle with OP as diameter, so obviously this is also semicircle and lower one is also semicircle. So any angle I draw in this semicircle, I'll find the angle to be 90 degree, because this is one of the properties of semicircles. At angle in a semicircle is always a right angle. So that proves one another thing, that the tangent PQ and the radius OQ are perpendicular to each other. Before I started about the tangent, I told you the property of the tangent is that tangent and radius of the circle are always perpendicular to each other. Why are they perpendicular? Because this angle is going to be always 90. Why this is going to be 90? Because this angle is inside semicircle. Angle in a semicircle is always a right angle. So OQP is equal to ORP is equal to 90 degree and OP is equal to OP. Common. Please understand that in these two right angle triangle, OP is the hypotenuse. OP is hypotenuse. Why it is hypotenuse? Because the side in a right angle triangle opposite to right angle is always hypotenuse, because the biggest angle in a right angle triangle is 90 degree, and the side opposite to 90 degree will be the biggest side, and it is called hypotenuse. So these two right angle triangles are congruent to each other. Triangle OQP is congruent to triangle ORP RHS. Right angle, one right angle is there, hypotenuse is equal, and one of the remaining sides are equal. So when this happens and triangles are congruent, then they are going to be equal to each other in each and every respect. Hence, PQ is equal to PR. So pair of tangents drawn from a point outside the circle to a circle are always going to be equal. That is why PQ is equal to PR. We have proved how to draw tangent. Then we have taught you that why it is 90 degree, why we said that tangent and radius are perpendicular to each other, and why did we say that length of the tangent is going to be always equal. In pair of tangent the length will be always equal. Why is it so? That also we have said. Now let us do question number 2. This was question number 1. In question number 2, I have draw two concentric circles of radius 3 cm and 5 cm. First of all, what are concentric circle? When we were discussing circles, we told you what are concentric circle. Concentric circles are circles with the same center but different radii, different radius. Draw two concentric circles of radius 3 cm and 5 cm. Taking a point on the outer circle, draw tangent to inner circle, measure the length and verify it. Now let us see what is he saying. He's saying that one circle of radius 3 cm. One circle of radius 5 cm. One circle is given of the radius 3 cm, one of the 5 cm. If I join this, O is the common center. If I take OA and P, so OA is 3 cm, OP is 5 cm. both the circles have the same center O, both the circles have the same center O, both the circles have the same center O, and their radii are 3 centimeter and 5 centimeter. Draw two concentric circles of radius 3 centimeter and 5 centimeter. We have drawn two concentric circles of radius 3 centimeter and 5 centimeter. Now he says draw tangent to the inner circle. This is the inner circle. From a point, taking a point on the outer circle. Let us take P on the outer circle. From P I have to draw tangent to these circles. The method remains the same what we discussed in the first question. We are going to bisect OP. Again, OP is how much? 5 centimeter. By chance, OA is how much? 3 centimeter. 3 centimeter is more than 5 centimeter. More than half of 5 centimeter. Take, already this arc is drawn. Take P as center and draw an arc at a distance of the same 3 centimeter and join. The purpose is to perpendicular bisect it. To perpendicular bisect it will come somewhere here. Let me take it like here. Suppose this is K. This is the midpoint of OP. K is the midpoint of OP. Take here center, open up your compass till O and draw a circle. Obviously that circle will be like this. Now this circle will cut the inner circle at 2 points. One point is Q and one point is R. He said join P to Q, join P to R. PQ and PR are two tangents. You have to write these steps of construction. Again, I will insist that you must write these steps of construction. You must write these steps of construction every time. It is the same thing exactly. What we have done is we have drawn two concentric circles, one of radius 3 centimeter, one of 5 centimeter with the center at O. And then I have drawn a line OP. I have drawn a line OP. OA is 3 centimeter, OP is 5 centimeter. And I have perpendicular bisected OP to draw a circle on OP as diameter. I have drawn a circle on OP as diameter, and that circle cuts the circle of radius 3 centimeter at Q and R, inner circle. Inner circle of radius 3 centimeter. So we join P to Q and we join P to R. Now he says you measure PQ and PR and then verify it. So what I'll do is I'll join this to this, I'll join this to this. Now this OQP or POQ in triangle POQ. It's a right angle triangle. It is a right angle triangle. POQ is a right angle triangle because this angle is right angle, because this angle is in a semicircle. Angle in a semicircle is always a right angle. Angle in a semicircle is always a right angle. So this is 90 degree. What is this distance OP? OP is given to be how much? 5 centimeter. OP is 5 centimeter. What is the radius of this smaller circle? 3 centimeter. So if I apply Pythagoras theorem in triangle OPQ, what does Pythagoras theorem say? That the square described on the hypotenuse in a right angle triangle, the square described on hypotenuse, which is OP square will be equal to this sum of the squares of the other two sides. That is OQ square plus PQ square. Now I know what is OP. OP is 5, so 5 whole square. OQ, I know it is 3 square plus PQ whole square. So 25 minus 9 will be equal to PQ whole square. It will be 16. PQ square is equal to 16. That will imply PQ is equal to 4 centimeter. PQ is equal to 4 centimeter. Because square root of 16 is 4, and since it's a distance we will always take plus, never negative. So PQ is 4 centimeter. We have, first of all, what he said, measure and record PQ. You can measure and record PQ, and then you have to verify it. Verify means use the Pythagoras theorem to find out what is the length of the tangent. And if both are coming equal, even if little difference is coming, it doesn't matter. Approximately it should come out to be equal if your construction is okay. This is the second question. Please write down the steps of construction every time.